We're now going to start another case study, and this is also revisiting something we've done before with a reactive implementation using WebFlux instead of using the synchronous approach using Spring Web MVC. And so we're going to show off a bunch of really cool things, demonstrating how a Spring WebFlux can be used to communicate between a client and a gateway that then communicates also asynchronously to a bunch of services that are running in the background. And this particular example is very important to understand because the next programming assignment is going to leverage some of the things we're going to talk about here. So it'll be helpful to get a bigger picture view of what's going on. So this also shows how to use the Eureka Discovery Service correctly. We looked at an earlier version that didn't really use Eureka in the right way. And now we fixed that so it actually uses Eureka correctly. So you'll get a chance to learn how that works too. So what happens here is when the server side starts up, we start Eureka first, and then we start the gateway and the applications. And they do various things to interact with Eureka in order to announce their presence and or register with Eureka so that when requests come in, the gateway knows where to automatically forward. And we go a little further than we did last time where we actually let Eureka pick the port numbers. So we have no hard-coded port numbers whatsoever, as you'll see shortly. The client sends requests to the API gateway and the one and only API gateway, so it's only got a single point of contact with all the backend microservices, much more consistent with modern practices, although monolithic applications still have their place. The API gateway takes the requests from the client, and then it uses Eureka to discover how to route them to the designated microservices. And again, we've really cleaned up the gateway. You're going to love what we've done with the gateway. It's way, way simpler, and that's because it uses Eureka correctly. The Eureka Discovery Service keeps track of the requests or the registrations from these microservice applications, and then it collaborates with the gateway in order to route things without requiring hard coding of any ports or host names. This is the part that's really cool. Now, the other thing that's going to be different here, we're going to have two different implementations of the microservices, each one using different types of database models. The handy application is going to use the R2DBC database, which is a reactive relational database, and it's going to be able to serve responses asynchronously. Super duper cool. The Zippy application is going to use the Java persistence architecture instead of using the R2DBC model. So this is a fully reactive database. This is a non-reactive database that we encapsulate with a little reactive flair so that it appears reactive to the client, but it's not fully reactive. But this one here is fully reactive, and it's very cool. And that's significant because that's what you're going to do in your next programming assignment. You're going to redo the database controller and the database service to use a fully reactive database instead of the JPA. Lots of moving pieces here that you can see. Eureka, of course, is used as the server-side discovery service. It's server-side discovery, not client-side discovery, because the gateway is what uses this mechanism along with the microservices. And we'll see a bunch of really cool things when we look at this in more detail about how it works under the hood using various declarative mechanisms in the YAML, the application YAML file. The gateway is the master of ceremonies that keeps track of the registered microservices and uses Eureka to figure out where they're running. And again, it's got a YAML file that configures everything it needs to do its job, which is really cool. I'll talk more about that. We might or might not get to that today, but we'll get to it next time. Then we've got the microservices. We've got the Zippy microservice, which is the one that uses the JPA and synchronous. It uses a synchronous database, but an asynchronous wrapper around that. And then we've got resources to set and configure all this stuff to work with Eureka and so on. The handy microservice uses the R2DBC database, which is fully reactive. Whoops. And it implements the R2DBC in its repository. That's what we're going to focus on. Again, we may not get to that today, but the next programming assignment requires you to understand how this works, so we'll spend some time on it. And it's also configured declaratively. We have some common classes that are shared between them. We took some time figuring out how to do this. It's very clever. We're able to share the quote schema, which is really the thing that defines the messages that go back and forth across the network and how they're stored in the database in a way that's usable by both R2DBC and JPA, which took some doing. In fact, if you take a look at the movies class in assignment 2B, you'll notice that we took off the element collection annotation from the vector field, and that was to allow it to work properly for both JPA and R2DBC, as you'll see here. Then finally, we have a quote driver, which basically runs everything and gets the result back. And we're going to use the quote client, which is, of course, now going to leverage the mechanisms that are available with HTTP interface, so we don't have to write those things by hand. We can use a declarative model. And there's also some ways to set names and port numbers. So that's the end of the overview of this particular case study. The thing that this case study does that's really cool is it's going to demonstrate the right way to use Eureka, the right way to use a gateway, and it's going to show off these different database models all wrapped up in reactive programming.